to take a little bit of time to explain in a little more detail the program that I discussed in class on Monday for carrying out Euler's method. So I did this in class. So here is the program that we discussed in class, and so you'll remember that Euler's method is the idea, which is encapsulated by this equation that I've labeled blue, that one can find the solution of an ordinary differential equation at the n plus first, or I plus first, time step from the solution at the ith time step by simply taking a simple difference. And what we wanted to do, the goal of this program, is to find out what happens if you apply Euler's method many different times. So let me just go through the lines of the program one by one so that you see what they mean. So this first line, clear all, clears all of the variables that are in the memory. So for example, just to show you, if I type in the command window x equals 10, if I then type x, then it remembers that it's 10. But if I clear all, and I type x again, it has no idea. The program has no idea what the command is. So h is the step size, and in this iteration I put it 0.001. Let me put it 0.1 just so it runs a little bit faster. We're starting out in an initial x value of 0. We're going to end up at 1. So this command basically creates an array of numbers which go from the initial value x0 to the final value x final with a step size h. And actually the easiest way to see what this says is just to type it in. So actually if I copy all of these lines here, so I just copied them, I'm going to paste them into the command window. So x0 is 0, x final is 1, and now x basically is an array of numbers which go from 0 to 1 with a step of 0.1, which is what the h value is. And so if we change h, like for example, if I made h 0.01 and I ran the same command again, then now if I type x, then you'll see it goes from 0 to 1 in steps of 0.01. So that's what these commands do. We then start out with an initial condition that y of 1 is equal to 1, and we step through for every x and apply Euler's method. Now, you might be confused by this here. So this says for I goes from 1 to the length of x minus 1. So let's find out what the length of x is. So if we look at x, so here's x again, and if I type the length of x, then it tells me that it's 101, and that's because there are 101 different elements in x. So this starts at I equals 1 and goes to the length of x minus 1, and then calculates the new y value. It goes to minus 1, length of x minus 1, because if I were to go all the way to the length of x, you'll notice that this command enters y. It basically takes the last value of x and computes the next value, and I'm interested in the value of y at x final, which is then set up correctly if I make this the length of x. Finally, I solve the ODE exactly, and then we just print out the answers. And that's how this code works. It might be worth showing you quickly another code, which I will post online, which implements the trapezoid rule. This is the rule that is discussed in the textbook in section 6.3 and goes beyond is more accurate actually than Euler's method. And here actually the operative command is that y at position n plus 1 is equal to y at position n minus 1 plus 2 times the step size times the function. And all I did to basically create this is to simply change this equation. So now y of I plus 1 is determined by y at I minus 1 and the value of the function at I. And I then simply had to initialize it. And in order to initialize this, since y at 3, so in order to specify y at 3, I need to know y at 1 and y at 2. I had to initialize y at 1 and y at 2. And then it will, this code will produce the result of the trapezoid. That's all.